Hello, welcome to this assignment. Today we're going to study the change of direction testing in high performance sports. We're going to do a comparative analysis between the Illinois agility test, the T test, the 505 change of direction test. We're going to learn about deceleration mechanics, asymmetry, and change of direction deficit. Why test change of direction? Because helps you to predict on-field performance, also to prescribe targeted training, helps to profile athlete phenotypes, screen for injury risk, also the return to play benchmarks, and helps you out to monitor adaptations. Change of direction ability is a distinct physical quality from linear speed. That's something very important to keep in mind. Change of direction versus linear speed versus agility. Change of direction is a pre-planned ability to break change of direction and decelerate. Is purely mechanical and a physical quality. Linear speed is a straight line acceleration and maximal velocity capabilities. Limited transfer to sharp turning ability. Agility is change of direction plus perceptual cognitive component. There's a response to a stimulus rather than a pre-planned pattern. There's an insight here as distinct yet complementary qualities with moderate correlations must be trained and assessed specifically. The three tests, high level overview. This is just an overview here. We're going to do to look for the Illinois agility test, which is a multi-directional flow weaving plus 180 turns. The T test is frontal plane dominance, shuffle plus back pedal, and 505 change of direction, single sharp reversal, maximal 180 degree turn. The primary quality of the Illinois agility test, flow and endurance, T test lateral control, 505 braking and eccentric. The rest of the components, we're going to see them inside each test. What is the strategic selection? You choose the test that mimics the specific mechanical demands of your sport. 505 is the gold standard for isolating braking mechanics. Illinois test general maneuverability. T test evaluates lateral and frontal plane competency. The Illinois agility test. This is the protocol, setup and dimensions. Is a 10 times 5 meter rectangular course, 4 corner cones defining the area plus 4 center cones spaced 3.3 meters apart from for weaving section. The movement pattern, you start prone, line down, you sprint 10 meters, 180 degree turn, weave back through the center, weave forward, and 180 turn, sprint 10 meters to finish. The typical performance, the total distance is 60 meters, around 60 meters. The average time is 16 to 18 seconds. Elite athletes is less than 15 seconds, and the primary demand is multi-directional. Test ability to turn from various angles and accelerate from prone position is a heavy metabolic demand due to duration. The T-test protocols and outputs. Setup and layout is a T-shaped course with 4 cones, 10 meter forward sprint A to B, then 5 meter lateral left to C, 10 meter lateral right to D, 5 meter lateral left back to the center, and 10 meter backward to start. It's the movement pattern. Requires forward sprint, lateral shuffling, and backpedaling. The hand touch required at the base of each cone total distance is basically 40 meters. The performance norms, typical times for team sports ranges from 9 to 12 seconds. This emphasizes frontal plane braking, lateral power, and body control. 505 change of direction test protocol is a 15-meter sprint approach to build momentum. Timing gets placed at the 10-meter mark. Single turning cone at 15-meter line. Timing protocol. Time starts when the athlete breaks the 10-meter gate, turns 180 degree at 15 meters line, and stops when they return through the 10-meter gate. 5 plus 5 equals 10 meter total time distance. The movement pattern, maximal braking from high velocity, pure 180 degree turn, bilateral testing is required. So separate trials for left and right foot turns. The key output, total time is 2 to 2.6 seconds. Change of direction deficit, isolation of braking ability, and asymmetry index. We will see this in a second. The deficit, change of direction deficit, represents the specific time cost of braking and changing direction, isolating mechanical efficiency from linear sprint speed. The calculation time, 505 time left, 2.40 seconds. The 10 meters sprint time, 1.7. The linear prediction would be 170 divided by 2, because the formula is the 505 time minus the 10 meters sprint divided by 2. That would give you that change of direction deficit. So what I was telling about the calculation example is that 505 time would be 2.40 seconds. The 10 meter sprint time is 1.70. This is an example. Linear prediction would be 1.70 divided by 2. That's 1.85. And the change of direction deficit is 240 minus 0.85. That's 0.55 seconds. The interpretation thresholds. Less than 0.40 seconds is elite athletes, excellent efficiency. 0.40 to 1 minute, train, competitive standard. More than 60, I'm sorry, I said a minute, is 0.40 and 0.60 seconds. That's for train and competitive standard. More than 0.60 seconds needs improvement because it has a poor braking. The target is to reduce deficit by eccentric strength and technique, not just speed training. The asymmetry analysis, the rationale, and the thresholds. The asymmetry index formula, well, let's define why to measure as asymmetry, because identifies limb dominance and functional deficit that may increase injury risk or limit multidirectional performance. What's the formula? Is slower minus faster divided by faster times 100. That's a percentage. So the interpretation thresholds, less than 5% normal, 5 to 10% it's moderate asymmetry, you have to monitor. 10 to 15, the intervention is recommended, and more than 15 is a high risk of injury and immediate actions should be taken. What's the clinical significance? An asymmetry more than 15%, more than 10 to 15% is linked to 2 to 3 times higher risk of non-contact ACL injury, especially in females, and hamstring strain, eccentric strength deficit correlate with increased strain risk during high speed deceleration. What actions should be taken? Implement unilateral strength and deceleration drills if more than 10%. The biomechanics and braking phase of the Illinois. Critical mechanic determinants, high peak horizontal braking forces are required to dissipate momentum. Eccentric strength is a limiting factor, it's 3 to 5 times body weight. The setup step that initiates braking maximizes braking impulse to reduce load on the final turn step. Lowering center of mass increases stability and optimizes horizontal force application vector for stopping. Drop 10 to 20 centimeters. Longer than sprint, it's more than 0.10 seconds to allow sufficient impulse generation for direction. The braking impulse, which is force times time, determines stop distance, not just peak force. And plant foot and reacceleration. The final foot contact, FFC mechanics, the plant foot lands lateral to the center of mass to create appropriate force vector for redirection. Optimal range for force absorption and subsequent power production. Ankle should be in 15 to 25 degrees. The knee around 60 to 110 degrees. The hip 40 to 70. Rapid switch from eccentric absorption to concentric propulsion. Neutral spine with slide forward lean, minimizing lateral trunk flexion prevents energy leaks. Coaching cue, push the ground away. The comparison on the braking demands and stress. Braking force, the Illinois agility test is moderate because it's 2 to 3 times body weight. Mixed angle demands. The T test is moderate to high, 2.5 to 4 times body weight. The 505 is high or max, 3 to 5 times body weight. Contact times, it's 0.20 to 0.32. It's variable on the Illinois. 0.25 to 0.35. Prolonged and shuffle transition on the T test. And 0.30 to 0.40 is the longest full reversal on the 505 change of direction test. Physiological stress, the Illinois, highly glycolytic demand, highly glycolytic demand. It has aerobic contribution. It's much more metabolic. The T test is mixed, neuromuscular plus metabolic. You need local muscle endurance, and 505 is basically neuromuscular. Central nervous system and structural damage. High mechanical stress. The primary limiter in the Illinois, turning efficiency and fatigue resistance. T test lateral strength and hip mobility, and the 505 eccentric strength and reactive ability. Athlete profiling, phenotypes and needs. Speed dominant on a 10-meter sprint, less than 1.70 seconds. That's fast. Change of direction deficit is poor. It has excellent linear acceleration and top speed. Struggles to dissipate high momentum. Inefficient braking mechanics. Training priority, eccentric strength, deceleration technique, braking capacity. Change of direction dominant, 10-meter sprint, more than 1.80 seconds, that's lower. Change of direction deficit, less than 0.45, that's good. Highly efficient at turning and reorienting. Superior eccentric utilization relative to strength, and lacks raw propulsive power for linear brakes. The training priority, max strength, linear acceleration, and plyometrics. Sport-specific application for soccer, field hockey, you can use 505 and the Illinois. For basketball and handball, you can use the T test and Illinois. For rugby, 505 and T-test. American football, you can use the 505 and Pro Agility standard. Tennis and racket sports, T-test and modified 505. The training deceleration progression, phase 1, weeks 1 to 3, technical foundation, low velocity approach, body control cues, sit back into the hips. Phase 2, weeks 4 to 6, velocity progression, 80 to 90% max speed, at angle variation, weight vests. Phase 3, weeks 7 to 9, maximal intensity, 95 to 100% approach, sport-specific angles and reactive components. And phase 4, in season, you need a maintenance, high-intensity microdose integrated into practice and monitoring the fatigue. What the eccentric strength methods, tempo squats, Nordic curls, tempo squats for slow controlled descent, Nordic curls at supramaximal strength for hamstring resilience, accentuated eccentric is a low overload training, flywheel training, variable resistance, and that's for inertial loading. All of them, we have seen them in the past courses. When to test and to monitor. If you are on a pre-season, that's the baseline and profiling. You have to run a full battery of tests to establish the benchmarks and identify asymmetries, more than 10%, target weaknesses in block 1, and in season, you monitoring and low fatigue, 505 test only because it's minimal volume, frequency every 4 to 6 weeks, and you have to monitor neuromuscular fatigue, track asymmetry changes. When you go to the off season, then you start development phase with monthly testing checkpoints, guide eccentric and power blocks, focus on change of direction deficit reduction, and you can use higher volume testing. Return to play with a progressive clearance, stage 1 T-test control, stage 2 505 for max braking, stage 3 Illinois for volume. The criterion, asymmetry less than 10%. Critical rule, avoid maximal change of direction testing less than 48 hours before competition due to high eccentric muscle damage and neuromuscular fatigue. How you interpret the results and decision flow. First, you calculate the deficit, then you assess the asymmetry, compare the thresholds, you identify the limiter and prescribe the block, then you retest and iterate. Practical application case, athlete shows 0.65 seconds change of direction, is poor, but only less than 3% asymmetry, which is good. Diagnosis would be bilateral eccentric strength deficiency or poor braking technique. Intervention, heavy eccentric squat plus technique drill. And the key takeaways here is that the distinct physical quality, the change of direction is mechanically distinct from linear spread, assesses and train it specifically based on braking demands. You use the 505 test as a gold standard for isolating braking mechanics and calculating change of direction deficit metric. It imposes high importance on eccentrics, helps to value the asymmetry thresholds. More than 10 to 15% warrants targeted intervention to reduce injury risk, helps you out on the training integration and also for the strategic selection, because the choose tests are based on sport demands, and flow versus braking, and retest consistently to monitor adaptation. Final thought: don't just train to go fast, train the ability to stop fast. Deceleration is a prerequisite for elite agility. And here are the references that I use for this presentation. Thank you very much.